Welcome, class. So today we are going to close out our look at Chapter 1 with exploring some ideas about problem solving and looking specifically at a specific method of problem solving that can be extremely useful when we're looking at problems in chemistry and other sciences for that matter as well. And this is what's called dimensional analysis. And it's essentially using units as a guide to solve problems. So it's what is sometimes called unit-driven problem solving. Now, we already did this a little bit a few sessions ago when we talked about converting from one within the metric system, so converting milliliters into liters or grams into micrograms, etc. Right? We were doing dimensional analysis, right? We were using units to guide our problem solving. Now, the reason this is so useful when we use measurements is that units are treated in large part just like the number is, right? Units can be multiplied by each other, can be divided by each other to cancel out, and they can be canceled, right? And so we can treat them just like numbers. So we can multiply and divide the numbers, but we also at the same time multiply and divide the units. And this is why it's so important to always include the units as we're going through our problem solving, because then we can easily see whether the units cancel or whether they don't, and then we can see, does it give us the units that we're expecting in our final answer. So this can make it a little bit easier sometimes to spot errors when we multiply instead of divide, or vice versa. Now, of course, this technique revolves around the use of conversion factors a lot. And conversion factors are simply, right, equalities, right? But typically with different units, like saying 100 centimeters equals a meter, right? That's a conversion factor. Now, conversion factors can be written in all sorts of different ways. It can be written as just saying 100 centimeters equals 1 meter. They can also be written as ratios, right? And this is how we'll use them when we do problem solving. So we can write 100 centimeters is equivalent to 1 meter. Or we could write 1 meter is equivalent to 100 centimeters. And we'll utilize these ratios, conversion factors, as we go through and we do the problems. And the way, whichever one we put on top or bottom is going to be dictated by our units again, right? What units do we start with? What units are we trying to give? So if we follow the pattern that if we start with a given unit, we set this up, and so, so we multiply, and we always have the desired unit on top divided by the given unit, and then that will give us the desired unit, whereas the given unit will cancel out. So we got this idea that the given unit that we start with, if we multiply by the desired unit over the given unit will cancel out and we'll be left with the desired unit. So that's sort of the basic idea that we're going to follow when we go through any of these. So let's put this into play and do a little bit of dimensional analysis. So a lot of dimensional analysis is simple units conversions. Now, sometimes these are very targeted, sometimes they're sort of go in multiple steps, so you just have to kind of understand where you need to go and what conversion factors you have available to you. So let's look at the first problem. So our given unit is quarts, and our desired unit is milliliters. Now, sometimes it's important to recognize that we may not be able to find a conversion factor that takes us directly from the desired unit, from the given unit to the desired unit. So I don't have a conversion factor, at least one that's easy to find, that goes directly from quarts to milliliters. But I do have one that I can look up that tells me that 1 liter equals 1.0567 quarts. So I can very readily go from quarts to liters. And then once I'm in liters, I can quite easily use the metric system to go to milliliters. Okay, so let's put this out following our dimensional analysis. So we're going to start with 1.35 quarts. And we follow the idea that we want to always take our desired unit over our given unit. So our given unit here is the quart, that one at the bottom, our desired unit, so in this case it's going to be liters. So I know that 1 liter is equal to 1.0567 quarts. And so if I do that, my quarts divided by quarts, right, the quarts will cancel out, and we'll be left with the desired unit. Now, we can get an answer here, and we can then take that answer and do the second step. Or, what I think a lot of you will probably end up doing is doing this as a series of calculations. So if we end up with liters here, now that's our new given unit. And again, our desired unit is ultimately milliliters, and our given unit is liters. And so I know from my metric system that 1 milliliter equals 1 times 10 to the negative 3 liters. Or if you're more comfortable and you've already learned it that way, you could say 1,000 milliliters in 1 liter. We just need to make sure we have it set up correctly. So here our liters would cancel out with our liters, and the only thing left is our desired unit, milliliters. So now it's just a matter of going through the math. So I'm going to take my 1.35 times 1 divided by 1.567 times 1 divided by 1 times 10 to the minus third. And if you do all that, you should end up with something like 1277.56. And this is, of course, going to be milliliters. Now, we cannot forget about significant figures. So, when we do these conversions, typically the number of significant figures in our initial quantity here is going to control the significant figures in our answer, because most often these units conversions are exact numbers, right? So we're not gonna let this quarts to liters conversion or this liters to liters limit the number of significant figures in our answer. So we have 3 here, right? So we're going to end up with 3. So that means I can go out 1, 2, 3. So I have 7. The next one is I have to round this to 8. But this is a little tricky, right? So this would have to be written as 1280 milliliters. So that has 3, but that's kind of ambiguous, right? Because I have to have that 0 there at the end, but no decimal point, because there's only 3 significant figures. So only these 3 numbers are significant. So really, the way we need to write this out is we need to put it in scientific notation and say 1.28 times 10 to the third milliliters. And that way we can clearly display our 3 significant figures and not worry about the ambiguity of that 0 that we have to have there if we were to try to write this as a decimal number. So follow the units. So let's try another one. But this one, we're going to be using some more complex units, because we can do this with all kinds of things. So here, we want to take a drug dose that's given in grams per pound of body weight, and convert it to a dosage in milligrams per kilogram of body weight. So we have to convert, top units and bottom units, right? So we want to go from grams to pounds to milligrams to kilograms. Well, it's no different. We're just going to have to look at our conversion. So we need the top number to go from grams to milligrams, and we need the bottom number to go from pounds to kilograms. So these are the two conversions we need to do. So if we start to write this out, with 0.012. Now, the way this is written is when we have these complex units, like density, for example, which we'll do another example here, and the number goes with the top unit, so 0.012 grams per essentially it's 1 pound. Now, we don't have to write out the 1, but we can say per pound. So if, let's say, we do the top conversion first. So we want to get rid of the grams, so we want the grams down here, we want milligrams on top. So if I remember my metric system, 1 milligram, 1 times 10 to the negative 3 grams, or 1,000 milligrams per gram, if you want to write it that way. So in this case, my grams cancel, and now I would have milligrams per pound. So I got halfway there. So now I need to get this pounds into kilograms. Now, this is an English conversion, so we're going to have to look up this conversion. So it turns out if you look at the back of the book, you can find a conversion that says that 1 kilogram is equivalent to 2.2046 pounds. So again, my given unit is pounds. So now we have to be a little careful because it starts out on the bottom. So this is the given unit. So I want the given unit up here to cancel. And since I'm trying to get kilograms on the bottom, that's what I want. So I want pounds over kilograms. So I have 2.2046 pounds per every 1 kilogram equals. And let's see, your pounds cancel out here and here, divide, so we end up with milligrams per kilogram. So we go through and do the math, and we end up with 26.455 milligrams per kilogram. Now, again, we can't forget about significant figures. So again, we're going to be guided by our original number here. And we have 2 significant figures here. So we're going to round this to 2 significant figures, so that would be the 6. So the 4 says I don't touch it. So this ends up being 26 milligrams per kilogram. That's the answer. Okay. Now, this last example is looking at a little bit back at density. So a little bit earlier we talked about density as the ratio between mass and volume. Now, the other very common use of density is to act as a conversion between mass and volume. Right? So I'm just going to write over here, density is often used to convert between mass and volume. So it's one of the probably the most common actually place where we use density is as a conversion factor, right? To allow us to say, if we know the mass of something, to convert it into a volume, or if we know the volume of something, to convert it into an equivalent mass. So let's look at our problem here. So our problem says I have 51.8 milliliters, and I want to get it into grams. So anytime you see this, right, so here it's a little different because we're not converting within the same type of unit. So here we were converting volume to volume and mass to mass, right? So here we're going volume to mass, right? It's this very specific kind of conversion, and density is what we use to do that. Now, since we are starting with mass, I'm going to need, with volume, I'm going to need the volume on the bottom and the mass on the top. So how are we going to use our density? So remember, when we have complex units, like I was saying, the number always goes with the top unit. So it's 1.32 grams per 1 milliliter. So 1.32 grams per 1 milliliter. So we're going to end up multiplying by the density. So my milliliters cancel out, and I end up with 68.376 grams. Now, we have to use significant figures. Now, I will say that when we use density, density is not an exact number, right? It is a measured quantity. And so the number of significant figures in our density will impact how many we express in our final answer. In this case, it doesn't matter because we have 3 significant figures here. We also have 3 significant figures here. So we're going to give our answer to 3. So that means we have 68 and we have the 3. The 7 tells me I round up. So I end up with 68.4 grams is the equivalent mass. So if you want to summarize how we're doing this, right? So density equals mass per volume. So that means if I want to get my mass, like I'm doing here, is going to be my density times my volume. So, in other words, if I start with the volume, I've got to multiply by the density to get to my mass. Now, if I'm starting with my mass and I want to get to my volume, right, we have mass divided by density. So density times the volume will give you the mass. The mass divided by the density will give you back the volume. So if you were starting with your mass, then you would need to divide by the density, right? Because the grams would have to be on the bottom, right, to cancel your units. So dimensional analysis, we can use it lots of times in units conversion, but we can use it in different kinds of problems as well as a way to guide us through to make sure the units are making sense, right? They should always cancel to give us what we need as our final units. Okay, so that brings what we want to talk about in Chapter 1 to an end. And so you want to be working through these example problems, and I will talk to you again about Chapter 2.